Welcome to your Algebra 2 Lesson 4.8 and 4.9. Today you're going to solve quadratic equations and inequalities. So that's your objectives for today. You're going to solve quadratic equations using the quadratic formula and solve quadratic inequalities in one variable. When we complete the square for ax squared plus bx plus c equals 0, we get the quadratic formula. And so solving for x, we get negative b plus or minus the square root of b squared minus 4ac all over 2a. You need to know this. You need to know it backwards and forwards. You need to be able to recognize that you can use it anytime you have a quadratic and you need to solve the equation. Okay, so we're going to solve x squared plus 3x equals 2. We do need to get it in standard form. So we need to subtract the 2 from both sides, and we need the whole thing equal to 0. So x squared plus 3x minus 2 equals 0. From there we can see what a, b, and c are, and that's very important because x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to know a, b, and c. So in this case, a is 1, b is 3, and c is negative 2. So we substitute in those values, and so we get x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 2 all over 2 times 1. So we need to simplify. So we're going to have 9 minus negative 8 in our radicand, and so 9 minus negative 8 is 9 plus 8, so we've got 17. So x equals negative 3 plus or minus square root of 17 over 2. So you have two solutions. I would like you to leave it in standard form, like it's written, but just so you know, there are two forms. There's two solutions. There's x equals negative 3 plus square root of 17 over 2, which is approximately 0.56, and x equals negative 3 minus square root of 17 over 2, which is approximately negative 3.56. Again, we want exact answers, so you can just leave it as negative 3 and then plus minus square root of 17 over 2. All right, let's solve 25x squared minus 18x equals 12x minus 9. We want to get 0 on that right-hand side, so we will subtract off the 12x and add 9 to both sides. And that'll give us 25x squared minus 30x plus 9 equals 0. It would be a real pain to try to factor that. Good thing we've got this quadratic formula. So a is 25, b is negative 30, c is 9. We'll substitute in. You do want to show the substitution step so that you can get partial credit in case you make a calculation error along the way. If you don't show this step, then I'm not going to be able to be as generous with partial credit. All right, so negative 30 is 30, plus or minus the square root of negative 30, the whole thing squared. Anytime you have a negative value, especially if you're going to put this in your calculator, you have to put parentheses around the base. So this is negative 30 quantity squared minus 4 times 25 times 9 over 2 times 25. So we're going to simplify. So you're going to get x equals 30 plus or minus, well, 30 squared is going to give you the exact same thing as 4 times 25 times 9, so you end up with 0. So we've got 30 plus or minus square root of 0 over 50. Well, the square root of 0 is just 0. 30 plus 0 is 30. 30 minus 0 is 30. 30 over 50 reduces to 3/5, and so you get x equals 3/5. Okay, negative x squared plus 4x equals 5. We want to write it in standard form so we can subtract the 5 over. So a is negative 1, b is 4, c is negative 5. Show the substitution step. The opposite of 4 is negative 4, plus or minus 4 squared minus 4 times negative 1 times negative 5 over 2 times negative 1. Simplify inside that square root sign, you get 16 minus 20, so you're going to get negative 4. So we've got negative 4 plus or minus the square root of negative 4 over negative 2. We want to simplify. Anytime you've got a negative inside that square root sign, the first step to simplifying is putting your I out. And we would have I times the square root of 4. Square root of 4 is 2. So all in all, it's negative 4 plus or minus 2I over negative 2. We want to simplify some more. Just take the real term, negative 4, and divide by negative 2. So that gives you positive 2. Then write down your plus or minus. 2i divided by negative 2 is going to be negative I, but the negative just changes the plus or minus, so you don't have to worry about writing that down. So it's 2 plus or minus I. And if you want to write it out as two answers, that's fine. You can put 2 plus I, 2 minus I, or you can just leave it as 2 plus or minus I. All right, so let's move on to solving a quadratic inequality in one variable. So to do this, you're going to write the inequality so that the quadratic is on the left and the 0 is on the right. You're going to factor the quadratic to find the zeros, and then you're going to make a number line and place the zeros on the number line. You're going to use a closed dot for less than or equal to or greater than or equal to, like we've done before, and you're going to use an open dot for less than or greater than, just like we've done before. Pick a value in each region of the number lines created by the endpoints at the zeros. You're going to plug in each value into the inequality statement to see if you get a true inequality statement or a false inequality statement. Okay, so let's see this in action. So we've got x squared plus x less than or equal to 6. All right, we want to rewrite it as x squared plus x minus 6 is less than or equal to 0. Then we're going to factor and mark the zeros on the number line. So let's see. X squared plus x minus 6, we need numbers that multiply to be negative 6 and add to be 1. So positive 3, negative 2 work. So we've got x plus 3 times x minus 2 less than or equal to 0. We look at just the equation part, x plus 3 times x minus 2 equals 0. And we find the two zeros for that. So x equals negative 3 and x equals positive 2. So we mark those on the number line. And then we have to pick values in each of the 3 regions that are created. See how there's a region where you have less than negative 3, between negative 3 and 2, and then greater than 2. You have to pick a value from each of those regions and plug it back into your inequality statement to see if you get a true statement or a false statement. Okay, so I'm going to pick negative 5 because that's less than negative 3. I'm going to pick 0 because it's an easy number to work with between negative 3 and 2, and I'm going to pick 5 because it's bigger than 2. So for negative 5, let's put it in the factored form. So we get negative 5 plus 3 times negative 5 minus 2, and I want to know if that's less than or equal to 0. Well, negative 5 plus 3 is negative 2. Negative 5 minus 2 is negative 7. Negative 2 times negative 7 is positive 14, less than or equal to 0. That is a false statement. That means that all these x values are not part of the solution. I'm going to plug in 0, so I get 0 plus 3 times 0 minus 2, and I want to know if that's less than or equal to 0. So I get 3 times negative 2, that gives me negative 6, less than or equal to 0. Negative 6 is less than 0, so that gives me a true statement. So all of the values in this region between negative 3 and 2 are part of my solution. Okay, I want to do the same thing with 5 to see if this region is part of my solution or not. All right, so I'm going to have 5 plus 3 is 8. 5 minus 2 is 3. 8 times 3 is 24. 24 is not less than 0. Okay, 24 less than or equal to 0 is a false statement. So my solution is the values between negative 3 and 2. So negative 3 less than or equal to x less than or equal to 2. The values there in between. Okay, so shade that in. All right, let's look at another example like this. We're going to solve x squared minus 2x greater than 15 algebraically. So I'm going to subtract 15 over. So I've got x squared minus 2x minus 15 greater than 0. I'm going to factor. So I get x plus 3 times x minus 5 greater than 0 because I needed values that multiply to be negative 15 and add to be negative 2. So positive 3, negative 5, that works. I set each of those equal to 0. So I have x plus 3 equals 0, which gives me x equals negative 3. X minus 5 equals 0 gives me x equals 5. And I mark those on the interval on the number line. Okay, so here's negative 3 and here's 5. And then I pick values that are in each region. So I can pick negative 4, I can pick 1, and I can pick 6. So I'm going to test x equals negative 4, and test x equals 1, and test x equals 6. So let's see. Negative 4 minus 5 times negative 4 plus 3, let's see, that gives me 9. And so, because I get negative 9 times negative 1, and 9 is greater than 0, so that's true. So all these values are going to be part of my solution. I'm going to try 1. 1 minus 5 is negative 4 times 1 plus 3. So negative 4 times positive 4 is negative 16. That is not greater than 0. That is a false statement. So those values between negative 3 and 5 are not part of my solution. And then finally, I'm going to test 6. 6 minus 5 is 1, times 6 plus 3 is 9. 1 times 9 is 9, and that is greater than 0, so this outer edge is part of my solution as the number line kind of gave away. Sorry about that. So we've got two pieces to our solution, x less than negative 3 and x greater than 5. So the solution is x less than negative 3 or x greater than 5. So as long as x is less than negative 3 or x is greater than 5, it is part of our solution. Okay, that's it. Try the problems to try on your own. Come to class ready to go over those. Come see me if you need help, or go back and rewatch part of the video. And thank you again for taking such good notes, and I look forward to seeing you in class.